Hello students, now we are going to start with Model Question Paper 2 2025-26 and this is the video of Part B Chemistry which carries total 25 marks. Already I have completed Part A Physics for this Model Question Paper 2 and I have uploaded this video. Please go through my channel. If you have not subscribed the channel, subscribe my channel for the more videos. And now I am going to start with Part B Chemistry in this video. So let me start with the first question. So here, first question will be again as the alternative. Four alternatives are given for each of the following question or incomplete statements. Choose the correct alternative and write the complete answer along with its letter of alphabet. So we have to write the answer as well as we have to write the letter of alphabet. Either it is A, B or C or D. So we have to write this alphabet. Remember, already it is given in the question itself. So you have to write that letter of alphabet. So question number 13, the functional group present in pentanal is. So we have to write the functional group present in this compound, that is pentanal. If you see this compound, pent means 5 carbon, ane means single bond and al, this al suffix indicates functional group. So al means it is aldehyde. So now we have to search for aldehyde group in these options. Option A OH, it is indicating alcohol. Option B CHO, it is indicating aldehyde. Option C is COOH, that is carboxylic acid, and option D is CO, that is ketone. So here the correct answer is option B, that is CHO. So here I have written answer. I have to write option B and my answer is CHO. Question number 14. Silver chloride turns grey when exposed to sunlight. This is because silver chloride. So we have to complete the sentence. So see what they have asked. Silver chloride turns grey when it is exposed to sunlight. So for this question, we should know the reaction of this. So silver chloride, that is AgCl, we are going to bring this in the contact of sunlight and there will be formation of grey color. That is due to what? We have to write the answer. So let me write first reaction for this. So what is silver chloride? Silver chloride is AgCl. So I'll write first AgCl. Then we have to bring this in contact of sunlight. So I'll write here HNu. HNu is nothing but sunlight symbol. It gives Ag and with this it will give chlorine gas. Chlorine gas means Cl2. We cannot write only one Cl. It is not stable. Cl is always stable as diatomic, that is Cl2. Because one Cl will form the bond with another Cl and it becomes Cl2. Therefore always remember we should write it Cl2. If it is 2, then on the reactant side is only Cl, 1 Cl. So to balance, we should write it here 2. Ag becomes 2. Therefore, this side also we should write 2Ag. Now the reaction is correct. If you see this reaction, AgCl, when comes in contact with sunlight, it becomes grey, they are saying. See, it is becoming grey. And grey is due to this Ag formation because this Cl is the gas. Once this gas formation takes place, it expels out. So what will remain in our watch glass? It will be only silver and therefore we have to search for silver. This AgCl has break, means it has decomposed and it has separated into Ag and Cl. Therefore search for this option that it gives Ag. So option A decomposes to form silver. Option B decomposes to form chlorine. Option C combine with oxygen and option D react with atmospheric moisture. Now if you see all the options, option A decomposes to silver, it is correct. It is decomposing and giving silver. Option B decomposes to give chlorine, that is also correct. It is giving chlorine. Option C combines with oxygen, it is not combining with oxygen. Option D reacting with moisture, there is no moisture because AgCl is coming in contact with only sunlight. Therefore, these two options are wrong. So we have to think in option A and B. In question, if you see, they have told it turns grey. And who is turning grey? Just because of silver it is turning grey. Therefore, we should write the correct answer as A. That is option A decomposes to form silver. So I wrote my answer. Answer option A decomposes to form silver. Now question number 15. To make iron to be hard and strong. You have to complete the sentence. We are going to make iron hard and strong. And to do this, what we can do with the iron? Option A. Carbon is added to pure iron. Option B, zinc is added to pure iron. Option C, fused with some other metals. Option D, anodization will be done. Means either you can add carbon or you can add zinc or you can add some other metals to this. Or iron is subjected to anodization process Anodization process, it is the process which is done for avoiding corrosion. So either you do anodization, they are saying. Actually, if you want to make iron hard and strong, carbon will be added. So that's why option A is correct. So write down the answer. Option A, carbon is added to pure iron. So these were three multiple choice questions from this part B chemistry. Now we'll move with theoretical questions on the next page. So now we'll start with next question, that is question number 7. Answer the following question. And here we have going to write, we have to answer 3 questions. Each question carries 1 mark. So total we are going to get 3 marks from this section. So question number 16 says, hydrochloric acid is considered as strong acid. Why? We have to answer. So they are asking hydrochloric acid, that is HCl. It is a strong acid. We have to tell why it is a strong acid. So answer, acids are substances that release hydrogen ion, means H plus ion, when dissolved in water. So always remember, if you think about the acid, any acid, HCl or it may be H2SO4 or it may be HNO3, when it is added in water, it always releases hydrogen ion, that is H plus ion. The strength of an acid depends on how many of these ions it produces in a solution. So all the acids, when they added in water, they release H plus ion. But the acid which releases more amount of H plus ion. So on the number of this H plus ion, the strength of that acid is decided. Because nearly all HCl molecule breaks up, the solution ends up with very high concentration of free H plus ions. And this high concentration is what makes the acid strong. So let me explain it clearly. So as it is told, whenever you take acid and add into the water, it always split. Acid will split to give H plus. So HCl, I'll write it separately here. HCl will split to give H plus and Cl minus. So this H plus is nothing but hydrogen ion, which I told here, hydrogen ion. So when this HCl is added in water, what happens? This HCl splits to give H plus. So this H plus combined with this water and it becomes H3O plus and Cl minus. So this H3O plus is nothing but what? It is a H plus ion. It is also, actually it is called as hydronium ion. Hydronium ion. H plus ion individually it is not stable, or H plus ion individually it is not available. So it always combines with water molecule and it will be available in the form of this hydronium ion. Hydronium ion is nothing but it is H plus, means hydronium ion means what? H3O plus, and this can immediately split to give H plus and water as usual separate. So it is nothing but H plus. So H3O plus, it is nothing but H plus. So any acid, this is about HCl. If I take HNO3, then HNO3 when it is added in water, it becomes H3O plus and NO3 minus. So here this H2O has took this H plus and became H3O plus, means what? All the acids, whenever you put in water, they will split. I can write it separately here also for HNO3. So HNO3 will split to give H plus and NO3 minus. Like this it will split. Even if I say H2SO4, that is sulfuric acid, this has 2 protons. So first one proton I will separate, H plus plus HSO4 minus. Like this it will separate. So all the acids, remember, when they are added in water, they all will split. See this, one H plus from HCl, this is the HNO3 H plus, this is the H2SO4 H plus. So all will split to give H plus. Then how you are going to see that, or how you are going to understand which acid is stronger? Remember, once you put these acids in water, all the molecules of that acid should split to give more and more of number of this H plus. And our acid which is asked in question, that is HCl, has the capacity to split all HCl molecule into free H plus ions. And if it happens, the solution will be having more amount of H plus ion. If it is having more amount of H plus ion, as I told, the strength is depend on what? It is depend on how many of these H plus ions are present. If H plus ions are more, the acid will be strong. If H plus ions are less, the acid will be weak. And here I told HCl will split completely to give more H plus ion, and therefore HCl is a strong acid. So this is the answer for this question. I hope you understood this answer. Now I'll move with question number. Question number 17 is, what is roasting in metallurgy? So here metallurgy, it is nothing but it is the process of converting ore into a pure form of a metal. In nature, we will get metal in the form of ore, that is impure form. That ore is taken to the industry, processing will be done, and then we will get a pure metal, and that whole process is called as metallurgy. So in that whole process, there is one of the method which is called as roasting. So here what is roasting, we have to answer. So see the answer. Roasting is the process of heating ore strongly in the presence of excess of air or excess of oxygen. So see, here roasting is nothing but roasting, it is a very common word. We will be using so many times in our kitchen. We will roast the chilies, or we will roast the potatoes like this. So what is roasting? Roasting nothing but we are heating something in a presence of or more amount of air or oxygen. It is called as roasting. It is mainly applied to sulfide ores. Remember, this process is mainly applied to what? Sulfide ores, means the ores which has sulfur, converting them into their oxides. So sulfides we will convert into oxides by putting more amount of oxygen. What is oxide? Oxide is nothing but the one which has oxygen. So we will add more amount of oxygen into the sulfide ore and we will convert it into oxide form and releasing the gases like sulfur dioxide. So see the reaction here I have given. I took zinc sulfide. So it is the ore of zinc because it is having zinc and one of the element it is sulfur S. So now what you have to do? We have to separate this sulfur and we have to separate our zinc metal. So what I am doing? I am going to add more amount of oxygen and heat it. So here heating we have to show it on the arrow. Let me show it on the arrow. So here the symbol, triangle symbol shows that it is heating process. So when we add this oxygen or when we heat this zinc sulfide in presence of this more amount of oxygen, now what happens? See, as I told, this sulfur combines with oxygen and becomes SO2, sulfur dioxide, and this is the gas, it is goes off. This is the gas which is goes off. Then what will remain? Only zinc will remain. This zinc will combine with oxygen and becomes zinc oxide. So see here, this sulfur place is taken by oxygen and becomes zinc oxide. So this ore earlier it was sulfide and now it is oxide because we have added oxygen. And why we did this? Because after converting into oxide ore, it is very easy to separate this oxygen. We will heat it more again. We will heat it more again, the zinc oxide, and we can separate our zinc and oxygen very easily. Therefore, roasting method is specially used for sulfide process. So remember, sometimes question may be asked, why roasting is used mainly for sulfide ore? Because roasting converts sulfide ores into oxide ores, and oxides ores we can easily convert into our pure metal by removing the oxygen. There is one more process which is called as calcination, which is there in the textbook. You maybe have studied. Calcination means what? Heating in presence of less oxygen or in absence of oxygen. So for those processes, we will not use any sulfide ores. We are using carbonates in which already there is oxygen. But here we are using the ores which don't have oxygen. See the sulfide ore, it don't have any oxygen. So now we will add oxygen in more amount and convert the sulfide into oxide ores. So remember, oxide ores are simple or easy to convert into pure metal. So this was the answer for this question number 17. I hope you are understanding the answer. Now we'll move to the next question on the next page. Question number 18. The first member of a group of carbon compounds is CH3Cl. Write the molecular formula and the name of the third member of this group. So here they have asked the homologous series of this member. So what is homologous series? It is the series or it is a group of compound which will have a difference of CH2 group. Remember, this is a group of compound or series of compound which will have a difference of CH2 group. So now by creating the CH2 group difference, we are going to create a series. So see the answer. A homologous series follows, here a homologous series follows a general formula and consistent structural increment. So in homologous series, all the molecules will be having the same general formula and even there will be some same or consistent into the structural formula. So the first member they have given CH3Cl. Now in the second member we have to just add CH2 because there should be difference of CH2. So once we add CH2, so you can see here already there is a one carbon. We will add one more carbon, so it becomes C2. Already there is 3H we are going to add another 2H, so it becomes H5. So C2H5 and Cl is as it is only one, so it is Cl. So it is C2H5Cl. Now the next is third member, because in the question they have asked third member. So now third member adds another CH2 group. Now this CH2 group we are going to add into the second member. So if you see the second homologous series compound, it is C2H5. When we add one more CH2, it becomes C3 and H7. Cl will not change. So C3H7Cl, and the name of this will be chloropropane. So I will explain it clearly. So see here, it was first member was CH3Cl. So we will add one CH2 in this. So this C added in this C, it was 1. This was 1. So it combines and becomes C2. So I wrote C2. It is 2 hydrogen here 2, here hydrogen 3. So when we add this hydrogen here, 2 and 3 will be added and H becomes 5. So H5. But here Cl is only 1. So as it is, Cl will be forwarded. So C2H5Cl. Now if you see here, there are 2 carbon. So whenever there will be 2 carbon, it will be eth. 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 And between these 2 carbon, there is a single bond. So if you want, I will split this here. C, C. Then these are the H, 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 H and H, 5H, and this is our Cl. So if you see there is a single bond between CC, so it is alkane, ane, so I will write ane. So it was ethane, but because there is a chlorine here, Cl group, so it will be chloro. So therefore we will write chloro. Sorry, it is chloro. So I will write it here, chlo and ro. Now it is correct. So it is chloroethane. So like this we have to name it. Now we will go for the third member. So now I will take this here. So it is C2H5Cl, and in this we are going to add again CH2. So it is C2. Now if we add this one, it becomes C3. And here H5 and here H2. So 5 plus 2 will be 7. So H7. Cl will be as it is forwarded. So C3, H7 and Cl. So let me write the structural formula. Now there are 3 carbons. So I'll take separately all the C. So write all H. How many H we have? Total 7. So 1, 2, 3, 4, 5, 6 and 7. So only one place is empty. Here we will write Cl. Now if you see, all the carbons have again single bond. So there are 3 carbon. 3 carbon means what? Prop. P-R-O-P. Prop. Single bond means there is ane. So propane. And there is a Cl group. So again it is chloro. So I will write it here, chloro. So the name is chloropropane. So I hope you understood this. Like this naming will be done. It is chloroethane. It is chloropropane. So this is the third member. In the question they have asked third member. So this is the answer, chloropropane. If they ask fourth member, what we have to do? Again we have to add CH2 in this compound. So take this compound here, C3, H7, Cl, and again add CH2. So what will happen? It will become C4 and H will become how many? 9 and Cl will be as it is. And like this it continues. Now they have asked for halides because it is Cl. They may ask you for alcohol, or they may ask you for aldehyde, or they may ask you for carboxylic acid. Just remember, whatever compound is given, in that compound you have to go on adding CH2, because in a homologous series every compound have the difference of this CH2 group. So this was the answer for question number 18. I hope you understood this question. I have explained very neatly and clearly. Now after this we are going to move with the next questions. So now we are going to start with question number 8, and here again answer the following question, and we have to answer 3 questions. Each question carries 2 marks, so total marks from this section we are going to get it is 6. So we are going to start with question number 19. When concentrated sulfuric acid is added to a test tube containing solid sodium chloride. So remember, you have to read this question very carefully because it is a very big question. When concentrated sulfuric acid means H2SO4, is added to a test tube containing solid sodium chloride, so it is NaCl. The gas X will be released. So when we mix these two, we are going to get one gas, and that gas is X. So we have to write what is this X, which gas is released. What are the ions formed when this gas is passed into water? So here the question comes. When this gas is passed into the water, what are the ions it will form? So this we have to write. So remember, we are going to write, or we have to write the ions when it is produced when the gas is passed into water. But before writing the ion, first we should know which gas. So therefore X we have to find out. Then next, what are the products formed when the gas X is passed into an aqueous basic solution obtained in chloralkali process? So here two activities they have missed. So what we have to do, after knowing the gas, first we have to see which ions it will form when it is passed into water, and then we have to take the gas and pass into the aqueous basic solution formed in chloralkali process. And which is the basic solution formed in chloralkali process? It is NaOH. So we are going to pass that gas into this NaOH. So take the gas, combine with NaOH, and write down the product which will form. So we will write the answer for this. So one by one, we have to write the. So once we understood which gas is released, then we can answer our first question. So therefore, when concentrated sulfuric acid reacts with solid NaCl, it produces hydrogen chloride gas, that is hydrochloric acid, HCl gas, which is nothing but our X. So we will write the question here, equation. So I took NaCl and I added H2SO4, that is sulfuric acid. Now what happens here? Na will react with SO4 and Cl will react with H. So it will give HCl and Na2SO4. So same reaction we can write it in a still simple way. So see here, NaCl, it is nothing but what? Na plus and Cl minus. So it has one cation, one anion, and this is going to react with H2SO4. H2SO4 also has cation, anion. H2 means H plus it is the cation, and with this it has the anion SO4 minus. So this is the anion. Now see what happens when we combine these two. Cation of NaCl combines with the anion of H2SO4. So this is cation and this is anion. So these two will combine. So like this. And then this Cl, it is the anion of what? NaCl, and H plus is the cation of H2SO4. So these two will combine. So I hope you are understanding. Cation of one compound will combine with anion of another compound. Anion of one compound will combine with cation of another compound. Because always negative and positive will get attracted, and positive, negative, negative will get repelled. So when these two combine, now what you are going to get? Na and SO4 will combine to give Na2SO4 like this. This is sodium sulfate. Why Na2? Because we have to balance the oxidation state, which you have studied already in 9th standard. And this H plus and Cl minus will combine to give here HCl. So like this we will get two products. So I hope you understood now why I wrote here Na2SO4 and HCl. So here this HCl which we have got here, this is in the form of gas. This is in the form of gas. This upside arrow indicates gaseous products, gaseous compound. So this is HCl, it is in the form of gas. So this is nothing but our answer, that is X. So once we understood what is X, now what is the next question? What is the question here? When we pass this gas into the water, just now we have answered in our previous question. HCl is the acid. Acid, whenever we added in a water, it splits to give what? It splits to give H plus and Cl minus. So these are the ions. So our ions are hydrogen ion and Cl minus ion. So see here, which forms hydrogen H plus and chloride Cl minus ions in water. Now what you are going to do? Again it is asked, what are the product it forms when the gas is passed to aqueous basic solution of chloralkali process? In chloralkali process, the basic solution which is formed is NaOH, sodium hydroxide. So we are going to react our gas with NaOH. So see here what happens, equation. So sorry, here I have explained little bit extra about this. So HCl dissolves in water to form hydrochloric acid, which dissociates to give ions. Which are the ions? Hydronium ion, that is H3O plus, or we can write it as H plus. And one more is chloride ion, Cl minus. And the same thing here in the form of reaction I have given. Now here you can see, when this gas is passed into basic sodium hydroxide solution, which we are getting from chloralkali process, what it forms here? HCl and NaOH. As I told earlier, HCl means what? Cation H plus, anion Cl minus. NaOH means what? Cation Na plus, and anion is OH minus. So see, H plus will combine with OH minus like this. So it gives what? It gives water, and this is the product. What is remaining now? NaCl, that is sorry, Na plus and Cl minus. These two will combine and gives NaCl. So these are our product, that is NaCl, sodium chloride, and one more is water. NaCl is sodium chloride, nothing but it is a salt. So why we are getting salt and water? Because this is a reaction between acid and base. Whenever acid and base combines, we will get salt and water. So this is the answer for question number 19. I hope you understood clearly. To see it is little bit big, but if you read this question carefully, one by one sentence, you will understand. So try to understand each and every sentence and answer one by one question. Don't answer it directly. First understand the question and write down the answer of first question. Then go for the second question and then you complete your answer. So after this we are going to move with the next question. Now the next question, that is question number 20, we are going to start. This question has a or option. So these both the questions we will solve in this video. So that is, write the properties of ionic compounds with respect to solubility, melting point, physical state and electrical conductivity. So here we are going to write the ionic properties with respect to these all the terms. So we have to tell how the ionic compound in terms of solubility, in terms of melting point, in terms of physical state and in terms of the conductivity, that is electrical conductivity. So first we will start. So answer number 1, we will start for solubility. So if you see, ionic compounds are soluble in polar solvents. Ionic compound means the compound which has ions or the compounds which are formed by the combination of ions, that is positive ion and negative ion, cation and anion. So, because these compounds have ion, these compounds are soluble in polar solvents like water, but insoluble in non-polar solvents, or we can say organic solvents like petrol or kerosene or ether, etc. So these all organic solvents we will not separate into ions, positive and negative ions, and therefore these ionic compounds will not dissolve in this petrol or kerosene. So this was about solubility. Second, we will see about its melting point. So as I told here, sorry, we are going to see now about the physical state first. So generally these ionic compounds are hard, brittle, crystalline solid at room temperature. So see here, at room temperature, ionic compounds are generally hard and brittle. Brittle means which can easily break. Those are called as brittle crystalline solid. Like you have seen salt, NaCl, the salt which we use for cooking. That salt will easily, if you take a salt and crush it, it will get easily break into these small crystals. So that is called brittle. Then this was about the physical state. Then third, we are going to see about the melting point or boiling point. Here in the question they have asked melting point, so you can write it for only melting point. Here I have written for both. Always ionic compounds have high melting point and boiling point. So as I told, ionic compounds has ions, positive and negative. And we know positive and negative ions will attract each other by the strong force, and the force is called an electrostatic force, and because of this force the ions will be strongly connected with each other. If this is a positive ion, if this is a negative ion, this positive and negative both will be strongly connected, and to break the bond between both or to break the attraction between the both we require more amount of temperature, and therefore we can say that ionic compound have high melting point and boiling point. Then the next one about the conductivity. So here they have asked electrical conductivity. These ionic compounds are poor conductors as solid. Very important. Ionic compound, whenever they are in the solid state, the ions are fixed. These ions are not moving. They are not movable. They are fixed. And if the ions are fixed, then there will be no positive, no negative ion. And if no ions, it cannot conduct electricity. Therefore, these are poor conductors as solid. But once you add those ionic compounds in water, they will get melt. They will convert into molten state or aqueous solution. Means what? The ions will get separated into the water. Positive ions, negative ions will get separated. They are free to move. Once you on the electricity into that aqueous solution or in that molten solution, ions will take that electricity and move. Means they conduct the electricity. Therefore, here I have written, or we have to write, poor conductors as solid and good conductors when they are in the molten state or in the aqueous solution. Remember this. And sometimes if they ask why they are a poor conductor in solid, you have to remember ions have fixed. Ions, all the ions are fixed in solid state. But in molten state, because all the ions are free, they can conduct electricity. So these are the properties of ionic compounds. So this is the answer. These are the 4 points which you are going to write for this question. Now we are going to move with or question. Or question, they are asking give reason. We have to give the reason. Here they have given two sentences. One is here and one is here. We have to write the reason for this. So we will start with the first one. Number 1, magnesium metal displaces copper in copper sulfate solution. So understand, read the statement first. Magnesium metal. When it is reacted with copper sulfate, CuSO4, it displaces that copper itself. So why it will happen? So here we have to focus on the electrochemical series. Electrochemical series means what? It is the series in which the elements are arranged in the increasing order of their reactivity. So let me write here that series. If you see the electrochemical series in our NCERT book, first there is a potassium, then comes sodium, then comes calcium. After calcium, there is magnesium. So I will write these all the elements to explain you people, because with the help of this series, it will be easy to understand. So I wrote here iron, then comes Pb, then comes hydrogen, and after hydrogen there is copper, and after copper there is mercury, and again there is silver and gold. So here this is called as electrochemical series. If you see, these all the elements are arranged in the increasing order, sorry, in the decreasing order of their reactivity. So I will write it here, decreasing order of reactivity. Very important, you have to remember. Decreasing order of reactivity means what? Here potassium is present at the topmost level. Topmost level means it is highly reactive. Then comes sodium. So sodium is less reactive than potassium. Then comes calcium, which is again less reactive than sodium. Then comes magnesium. So as we move down in this series, the reactivity will be go on decreasing. So I told here after mercury, there is silver and then there is a gold. So gold at the last. So gold is less reactive compared to these all the elements. So with the help of this electrochemical series, we can answer this question. So here they have told, they are asking magnesium metal displaces copper in the copper sulfate solution. So the answer is magnesium element is placed higher in the series than copper. So where is our copper? Copper is here at the bottom and magnesium is at the top. So if you see the series, who is more reactive? If we compare both, magnesium is more reactive than our copper. So if they are kept separately, then there will be no problem. But if you combine these both, if these two comes in contact with each other, then there will be comparison between the reactivity. Then whichever is more reactive will start reacting or replacing the other one. Therefore, so I'll read it. Magnesium element is placed higher in the series than copper. So by this, we can say that magnesium is more reactive than copper. Thus, when magnesium reacts with copper sulfate, it replaces copper and forms magnesium sulfate. So see the equation. This is magnesium. This is copper sulfate. When these both comes in contact, magnesium is more reactive. So it will go and replace this copper and magnesium becomes magnesium sulfate and copper will come out. So this is the reaction. This reaction is called as displacement reaction, where one metal ion is displacing the other. And remember students, this displacement is depend on reactivity. Whichever metal is more reactive, that will displace the less or replace the less reactive metal. Now in this question they have asked magnesium and copper. In the other question they may ask the other element. They may ask calcium and aluminium, aluminium and iron, zinc and iron, etc. Just you have to remember this series. And to remember this series, there are many more tricks. So remember, use those tricks, and with the help of tricks, you remember this series. With the help of series, you can answer for any question. So this was the reason for question number 1. I hope you understood this answer. Now I am going to move with second one. So second is sodium metal is stored in kerosene. This is a very important question. Many of the time this question will be asked. Even sometimes it is asked in multiple choice. So remember this. Sodium metal is stored in kerosene. Answer is because it's extremely reactive, because it is extremely reactive with air or oxygen and moisture. So whenever we keep this sodium metal into the environment, it is highly reactive. It immediately combines with air. Air means oxygen. It immediately combines with moisture. And if it get combined, it causes it to ignite or explode. It explodes immediately, and because of this we are going to store it in kerosene. Once we keep this sodium in kerosene, it will be not coming in contact with this air or moisture, and therefore kerosene provides a safe non-reactive barrier preventing these hazardous reaction. Means if you store in kerosene, because it will not come in contact with air or moisture, oxygen or moisture, these all the explosion igniting process all will be prevented, and we can keep this sodium safely. For more time we can store this sodium sodium element. So this is the answer for this question number 2. So I hope you understood the answer of question 2 also. If you are not subscribed my channel, please subscribe my channel and share my videos with your friends. Now after this we are going to move with the next question. Now we are going to see question number 21. Again, this question has the or option. So we will see the first one. So that is, explain the cleansing action of soap on dirt. This is also important question. Many of the times it will be asked, and already I have solved this question in the earlier model question paper. I hope you understood this answer, and the same way I am going to explain here also. So understand answer for point one. And why I have written here points, because it will be easy to read for the invigilator while correcting your paper. Whenever you feel your answer it is in the form of some 5 to 6 lines, then try to write that answer into points, one, two, or you can write A, B, C, D, or you can use bullets, because it will be easy to read, understand, and to give the marks. Because sometimes by seeing your points, marks will be allotted. Suppose for this question it is 3 marks, then for first point 1 mark, then for second point 2 marks, then for third point it will be 3 marks. So it will be easy to give the marks for your answer. Therefore, whenever you feel your answer is lengthy, try to write in points. So now we will see the answer. First one, most dirt is oily in nature. So remember students, whatever dirt we imagine, that will be mostly oily in nature. And as you know, oil does not dissolve in water, because oil is what? Just now we have seen, it is a non-polar substance, organic substance. And water is what? Polar substance. And therefore oil will not dissolve in water. So we have to add something which can make this oil to dissolve in the water, and that work will be done by the soap. So see here, the molecule of soap are sodium or potassium salts of long chain of carboxylic acid. So what is soap? Soap is nothing but sodium or potassium salts of long chain of carboxylic acids. The ionic end of soap interact with the water, while the carbon chain interacts with the oil. So whatever soap we have, or the molecule of soap we have, it has two ends or two parts. One is ionic and the other one is called as carbon chain, or it is called as hydrocarbon end. So one is ionic end and one is hydrocarbon end. So these two ends, one end will react with the water, other end will react with the dirt, and with the help of this process we can easily remove the oil from this clothes, or we can easily remove the dirt from the clothes. So see here, I will write the formula of the soap. So generally soap molecule is shown like this. I told it is a long chain of, see here, it is a long chain of sodium or potassium salts of carboxylic acid. So this is the long chain which has carbon-carbon bonds, and at one end there will be carboxylic group like this. So if it is a sodium, then it is called as, we have to write it Na plus. If you say potassium, then in place of Na plus we can write K plus. So this is a long chain of sodium or potassium salts of carboxylic acid. So this long chain is called as hydrocarbon part. This is hydrocarbon part. And the another one, this is called as ionic part. I hope you understood this. This you have to remember first. This is ionic part. So ionic part always dissolve in water, and hydrocarbon part always dissolve in oil. Hydrocarbon part will dissolve in oil, because these both are non-polar and these both are polar. So see, with the help of these two ends, we are going to clean the dirt from the cloth. Now see how we are going to clean the dirt. Point 3. The soap molecule thus forms a structure called micelle, where one end of the molecule is towards the oil droplet, while the ionic end faces outside. So once we put our soap into the water, or once we put our soap into the bucket containing water molecules, so this soap will be having many molecules. So this is one soap molecule. Such type of, there will be many molecules, and these all the soap molecule will arrange in the formation of a circular shape like this, and this shape is called as micelle. M-I-C-E-L-L-E-S. This is micelle. So if you see this micelle, in this each and every molecule of soap will arrange in such a way that this long chain, which is called as hydrocarbon part, will be towards the center, and this ionic part, that will be away from the center. See, it is towards the water, and this hydrocarbon part will be towards the dirt. So this center, whatever yellow color dot you can see, this is, imagine, our dirt. This is a oil droplet or a dirt. And for this molecule, you see, this zigzag line is called as hydrocarbon part of the soap, and this circle is called as ionic part of the soap. Now what happens? Imagine, imagine this is one bucket, and inside this bucket there is a water. So everywhere beside this there is a water. So this all is water. Now see, this all is water, and now you will understand why this ionic part is away from this dirt, because this side there is a water molecule, and ionic part and water both are polar, so these all will get attracted each other. And oil is at the center, and this is the hydrocarbon part, so both are organic, so these are attracted towards the center. Like this, the micelle will be formed and it will be arranged on the, it will be fixed on the dirt. Now after formation of micelle, once this hydrocarbon part is combined with the oil or the dirt on the cloth, oil and hydrocarbon both are organic, therefore these all the hydrocarbon ends will dissolve in this dirt, will all dissolve in this dirt. I hope you are understanding what I told. Organic solvent are non-polar. Oil is also non-polar. So this zigzag end, which is called as hydrocarbonate, that is also non-polar. Our oil is also non-polar. So both are like. Therefore, these both will dissolve with each other. These both will mix with each other, and they will separate this dirt from this cloth. Once this formation takes place, once this mechanism gets complete, when we shake our cloth in this water, because of the shaking process, these all the water soap molecule will go away from the cloth. And when they're going away from the cloth like this, one by one, while going, they will take the dirt from this cloth and goes away. Why they're taking the dirt? Because this hydrocarbon part is fixed with the dirt. Those both have been combined because they are like solvents. They both have combined. They have reacted. They have combined with the dirt. Once we shake our cloth in the water, once this soap molecule comes out, it takes that dirt also and comes out. And this process is happening with this, all the soap molecules. If every molecule will take little bit of dirt from this cloth, then all the dirt will be removed. And by this process, our cloth will get cleaned. This same thing I have written in the notes. So I'll read the next point. Third point I'll read once again. The soap molecule because thus forms a structure called micelle, where one end of the molecule is towards the oil droplet, while the ionic end faces outside. This forms an emulsion in the water. So this formation of this condition is called as emulsion. The soap micelle thus helps in pulling out the dirt in the water, and we can wash our clothes clean, and this is only called as cleansing action of soap. It is very easy to remember. It is like a story. Once you should take a bucket, take water, then put cloth, dirty cloth, and then put soap. All the soap molecule form a micelle. Micelle will go and fix on the dirt. So like this, one by one step you have to remember, and same all the step you have to combine and write your answer. So this was the answer for question number 21. I hope you understood. I have explained very neatly and clearly. Now we will see the OR option from this question, and the question is carbon atoms do not form C plus 4 cation or C minus 4 anions. Why? First let me write this C plus 4 and C minus 4 correctly. So this C plus 4 we have to write it like this. 4 plus should be on the head of the carbon. Even this C4 minus should be like this. So the question is carbon atoms do not form C plus 4 as well as C minus 4. Why? We have to answer. The answer is very simple for this. So see here, carbon. Carbon cannot form C plus 4 or C minus 4. Carbon cannot form anion and cation. Carbon always share electrons and forms covalent bond. This already we have studied in our carbon and its compound chapter. Why it is so, that we have to answer. So see here, carbon atomic number is 6. Carbon atomic number, it is 6. So I will write it here. Atomic number of carbon, it is 6. And if it is 6, then electronic configuration means arrangement of electrons into the different shells. If you focus on that, then we have shells K, L, M, N. Total 6 electrons we have. So arrange the electron, distribute the electron. K shell has the capacity to take only 2 electrons. So I'll write it 2. So out of 6, remaining is 4. So I'll write it remaining 4 in the L shell, because L shell has the capacity to take 8 electrons. So therefore I will add all 4 electrons into the L shell. Now if you see, This L shell is the last shell and last outermost shell, and outermost shell will try to occupy 8 electron or try to occupy octet. Octet means 8 electron, and to attain that octet either it will take the remaining electrons whatever it want, or it can lose those electrons completely and the earlier shell will become the last shell. So here what it happens, L L shell, if it want to complete the octet, either it has to take 4 electrons or it has to lose 4 electrons. If it takes 4 electrons, then it will become 8. If it lose 4 electrons, this L shell will get empty. Then which is the last shell? K shell is the first and last shell, and K shell capacity is already 2, and which is already satisfied, and then our carbon atoms will get stable. So this is the case actually. But what happens? Now see, first point, losing 4 electron needs immense energy, that is high ionization energy, making C plus 4 unstable. As we all know, whenever any metal loses the electron, if it losing first electron, then only it requires more energy. If it loses 2 electron, it requires more energy. And now here, if you see, carbon has to lose 4 electrons. It requires a large amount of energy. The removal of energy, it is also called as ionization energy. Whenever any metal loses the electron, it is called as ionization. So here carbon has to lose 4 electron. 4 electron means it requires immense energy, and because of that this process is unstable. Then what about the second option? Instead of losing, let this carbon takes 4 electron, it becomes 4 plus 4 8. But see what happens, carbon atomic number is 6, means carbon has 6 electrons as well as 6 protons. If you see, inside the nucleus there are 6 protons and outside the nucleus there are 6 electrons. And now if we add another 4 electrons to make this 8, then outside already there are 6 electrons. If you add another 4, total it becomes 10. So electrons will be 10, but protons we are not at all changing. Protons are as usual 6. Protons are positive, electrons are negative. So 6 positive charge and 10 negative charge, it will become unstable. These 6 protons cannot manage those 10 electrons, and therefore here I have written the small nucleus can't effectively hold 10 electrons. 6 protons plus 4 gained electrons, and therefore C minus 4 is also unstable. I hope you understood. I'll repeat once again. So here what I'm telling, atomic number of carbon is 6, means it has 6 protons and 6 electrons. If you add another 4 electrons, then electrons becomes 10, but protons remain 6. So positive charge are 6 and negative charge becomes 10. So these 6 protons cannot handle those 10 electrons, that is the extra 4 electrons which we have added, and therefore C minus 4 is also unstable. So C plus 4 is also unstable because it requires large amount of energy to lose 4 electrons. C minus 4 is also unstable because 6 protons cannot handle 10 electrons, the 4 which we have added extra, and therefore carbon do not form C plus 4 and C minus 4, and therefore carbon what it do? It forms covalent bond by sharing the electrons with the other element present beside it. So this was the answer for this question, that is the option question of this 21. I hope you understood this question. Now we are going to move with the next question. Now we are going to solve with question number 9. It says answer the following question. Here we are going to answer 3 questions. Each question carries 3 marks. So total we are going to get 9 marks from this section. So question number 22 we will start. Balance the following equation. Very easy question. That is, we have to balance the equation. And these all the equations which are there in this model question paper all are very easy. So we will start with the first one. So here Mg plus N2 magnesium plus nitrogen gives magnesium nitride, that is Mg3N2. So if you see this reaction, here Mg is 1, but here Mg is 3, and here N2, and here also it is N2. So just we have to balance only magnesium. So here Mg is 3. If you write it here 3, then the reaction will be balanced. It's so simple. Let me write the reaction once again down. So I'll write it here once again so that it will be easy or neat to balance the reaction. So answer, I'm going to write here Mg plus N2 and it giving Mg3N2. Now if you see, as I told, here Mg is 1 and 2, so it is 2 already, but here Mg is 3 and here again N is 2. So what is balancing? Balancing means number of the atoms on the left hand side should be equal to the number of atoms on the right hand side. So N2 and N2, if we see, it is already balanced 2 2. It is correct. But Mg is 1 on the left hand side and Mg is 3 on the right hand side. So how to make it 3? Just we have to write it 3 here. Once you write it 3 on the left hand side, then this 1 will become 3. So I will make it 3. Now if you see both the side, it is 3 and 3, so this is also balanced. So see, this is also balanced, and now this reaction is the correct balanced reaction. So I'll write it correctly balanced reaction down. 3Mg plus N2 gives Mg3N2. So this is the balanced reaction. Now we are going to move with the next reaction. So I'll write the reaction down first and then we will start balancing the reaction. So answer, what is our reaction? It is NaOH, then plus. So here I am going to write H2SO4 and this is going to give Na2, sodium sulfate, Na2SO4, and one more product is water, that is H2O. Now if you see this whole reaction, first write down the number of reactant on the product side as well as on the reactant side. So see here, we will write it here. Now if you see, sodium is how many? 1. So I'll write it 1. Oxygen is how many here? 1. So I'll write it 1. Hydrogen is also 1. Write down as usual. Here also there is a hydrogen 2. So sorry. So here it is 2. And again here there is yes 1. And again there is the oxygen 4. So we will combine these all. So if you see, I will combine this oxygen and this 4 oxygen. So total oxygen will be how many? Total oxygen will be here 5. So write down 5. Hydrogen also, here there is 1 and here there are 2 hydrogens. So if I combine these two, I have hydrogens total 3. So this is 5 and this is here 3. Now what we have to do? We have to move on the right hand side. Here sodium is 2, sulfur is 1, oxygen, see here how many? Oxygens are 4. This side hydrogen 2, again there is a oxygen, it is 1. So oxygen here also and there is this side, so I will combine these all and then I will write oxygen 5. So this is the case. If you see this whole equation, only sulfur, here also sulfur 1, here also sulfur 1. So it is balanced and remaining everything we have to balance now. So now if you want to balance this reaction, what you have to do? First focus on sodium. Here sodium we have 2. This side sodium is 1. So how to make this side 2? Because this already Na2 we cannot decrease. So this NaOH we can increase 1 Na. So I'll write it here 2. Once I write this side 2, Na will become 2. Yes, with this oxygen also it was 1. Now it will become 2 and total will change. Hydrogen was 1, it becomes 2 and again total will change. So let me change those all. So see here I am doing the correction. This oxygen became 2, so I'll write it here 2. If oxygen becomes 2, then these 2 oxygens, these 4 oxygens total will be 6. Hydrogen it was 1, now it became 2. These 2 and these 2 total becomes 4. So this is the change what we did now. Now if you see sodium 2, this sodium 2, it is balanced. Now we are going to focus on oxygen and hydrogen. Now see this side it is 2, 2, 2, this side also it is 2. Hydrogen this side is how many? 6. If you see this, hydrogen it is total, not hydrogen, it is oxygen actually. Oxygen it is total 6. And this side our oxygens are how many? Only 5. This side our hydrogens are 4 and this side our hydrogens are only 2. So how to make these 2 hydrogens 4? So we will write it here 2. Once I write this side 2, see here, this became 4. This also became 2. And with this 2, our total oxygen became 6. Now just focus. This hydrogen also balanced. This whole hydrogen also balanced. That is how many? These 4 hydrogens and these 4 hydrogens. Oxygen is 6. This is also 6. So here oxygen is also balanced, and in this way we have balanced our whole equation. So this is a trial and error method. You have to just go on using the numbers, different numbers, and multiply and try. So the balanced equation will be like this. So I'll write down here 2NaOH plus H2SO4, and it is going to give Na2SO4 plus 2H2O. Now see. So this is the balance equation, that is second one. Now we'll move with the third one. In third one, if you see, first write down that equation down once again. So in that we can do our trial error process. So what is the equation? AlOH thrice. Very important, this thrice you have to remember. Now here Al2O3. Before writing Al2O3, we have to leave some space to do this trial and error. Same way, before writing H2O also we have to leave some space. Now write down number of atoms. See here Al how many? 1, only 1. I'll write it 1. Then this side see here how many? OH is thrice. So after the bracket there is 3. So this 3 is applicable for both oxygen as well as hydrogen. So oxygen is also 3 and hydrogen is also 3. So this you have to remember. This 3 is not only for hydrogen, it is for both. There is, because of that there is a bracket. So this side, right side, if you see, aluminium it's 2 and oxygen it is here 3, and here also there is one more oxygen, that is 1, and this 2 if I combine, total oxygen on the right hand side it is 4. And what about hydrogen? Hydrogen we have 2. So this is the case. Now to balance these all, first we will balance aluminium. So here aluminium we have 2. So this side we will write it 2. Once I write this side 2, everything will change. What all will change? See here, this side, if this one aluminium becomes 2. Already here there was 3 oxygen and we have written here 2. So we have to multiply this. 3 2s are 6. So this will become 6. Here it is 6. Same way hydrogen also will become 6. So I will do these corrections here. So I will remove these all and then I will make the correction. Here aluminium got 2, oxygen became 6, and same way hydrogen also became 6. Now see, aluminium is already balanced, 2 and 2 it is balanced. Now focus on hydrogen and oxygen. Hydrogen how many we have? 4. This side hydrogen 6. So we cannot decrease this side hydrogen on left hand side. So how to make on the other side hydrogen as 6? We have 2 hydrogens. So if I write it here 3, 3 2s are 6. So this hydrogens becomes 6. And here oxygen also became 3. These 3 and these 3. So this total also became 6. And such a way oxygen, hydrogen also got balanced. So I'll write it here, balance reaction. So 2AlOH thrice here gives Al2O3, and then we will write 3H2O. So this is the balance equation, that is the third one. So like this we can balance any reaction. So remember, as I told, it is just a trial error method. You have to practice more and more reaction, then you will get a practice and you can easily balance any reaction. But remember, you have to sit with pencil and eraser. Eraser, pencil will help you to balance the reaction. You go on taking one by one number, multiply it and check. If it is not, rub that number, then take the next number. And like this, we can balance any reaction. I hope you understood this question, that is question number 22. Now the next is OR question. So here, convert the following chemical reactions into chemical equation. So here chemical reaction is given in the form of sentences, and this sentence we have to convert into the equations by using the symbols of these chemicals. So first one we will start. Copper react with concentrated nitric acid. So copper and concentrated nitric acid, we are going to react it here. So if you see, copper symbol is Cu, concentrated nitric acid symbol is HNO3. So we have to combine Cu and HNO3. So let me write the reaction for this. So as it is given, so I'll write first Cu, that is copper, it is solid. So I write it here S, plus HNO3, it is concentrated. So there is no water in this. So I'll write here CONC, that is concentrated. And when we combine these both, now see what happens. Copper is a metal, so it is electropositive, and this electropositive will try to react with the negative ion. And if you see here in HNO3, it has positive H plus ion, and a negative here NO3 minus ion. So this Cu will combine with this negative, that is NO3 minus ion. And we know copper oxidation, it is plus 2 or 2 plus, you can write plus 2 or 2 plus. So this Cu plus 2 and this NO3 minus 1, if you combine these two, what formula we are going to get here? We are going to get CuNO3, it is twice. So CuNO3 twice we are going to get. So we will write our one of the product is CuNO3 twice. This is one of the product and this is a aqueous solution. So I'll write AQ, aqueous solution, plus. Now after writing CuNO3 twice, what we will think? We will get a hydrogen here. But because this acid is concentrated, it is a strong oxidizing agent. And this strong oxidizing agent will oxidize this NO3 as well as hydrogen. Oxidize means it adds oxygen and therefore this hydrogen will oxidize to become water, that is H2O, water. H2O, and this nitrogen will oxidize to become NO2, that is nitrogen dioxide. This is a gas, so I'll write G, and this is a liquid, so I'll write it here L. So this is our reaction, and now we have to balance this whole equation, and to balance, here we have to write it 2H2O, and here we have to write 2NO2, and then with this our HNO3 also will change. Now see here, H are 4, 2 2s are 4. Then here if I write it 4, see N is balanced or no, N will become 4. This side it is 2N and this side it is 2 2s are 4. So it will become total how many? It will become 8. So we will write it here 4, this all 4H, 2 2s are 4. 4 3s are 12. Yes, it is balanced. So this is our balanced chemical equation for the first one. Now we'll move with the second one. If you see the second one, it is silver nitrate and KBr, potassium bromide. So we will take here silver nitrate. So I will write AgNO3, and they have said it is solution. Solution means what you have to take? We have to take aqueous condition, AQ. Then plus it is going to react with potassium bromide, that is also again solution. So I'll write it here KBr. So I'll write AQ, aqueous solution. What is aqueous? The solution which is prepared in water. Once you put the salt in water, whatever solution we will get, we will write the condition as aqueous. And when these will combine, what you are going to get? So see here, these silver nitrate, if I split, I am going to get cation Ag plus and anion NO3 minus. Same way, if I split this KBr, cation I am going to get K plus, anion I am going to get Br minus. Here it is important to remember these oxidation states or valencies. So Ag plus, it is a positive ion combined with a negative ion of another element, that is Br minus. NO3 is negative, it combines with the positive ion of the other one, that is K plus. And if I combine such a way, I am going to get the product, that is Ag plus Br also minus. So I will get AgBr. So I'll write it here AgBr, silver bromide, it is in solid condition. Plus with this I am going to get KNO3, potassium nitrate, and this is in aqueous condition. So I'll write it AQ for this. This is the equation for second one, that is silver nitrate solution is added to potassium bromide solution. And now here the third one, zinc oxide is reduced to by coke. Zinc oxide means ZNO, coke means it's carbon, and the symbol for carbon is C. So here if I write the reaction of this, it will be like this. Zinc oxide ZNO, it is in solid condition oxide. I will combine this with the carbon, that is also in solid condition. I'll write yes. And if I combine this, reduction takes place. Reduction means what? Removal of oxygen. So this oxygen is removed. And who will take this oxygen? Carbon will take that oxygen. Therefore, I am going to get zinc plus CO, carbon monoxide. Zinc is solid, carbon monoxide it's a gas. So I'll write it here G. If you see, this reaction is also balanced. Second reaction, there was no need to balance. Only the first equation we had to balance. So this was the answer for this OR option. That is writing a chemical equation. So I hope you understood this, how to write the reaction. The main important thing in this equation, in this answer or for this question is you should know the symbols of all the chemicals or the elements. And if you know the symbol, you should able to write the formulas of all the chemicals. Formula is very important. And to write this formula, we should remember these oxidation states. You can see here, this plus 2 is the oxidation state of copper. minus 1 is the oxygen state of this NO3. Same like that, here also I have written Ag plus NO3 minus. So these oxidation states you have to remember. If you know these states, easily we can write the formula like this. And if you know the formula, then we can easily complete the reaction. So this is the answer for option for this question. I hope you understood this question. Now we are going to move with the next question. Now the next question, that is question number 23, which has A, B and C option. So we will see A first. What is acid rain? So we have to write what is acid rain. So answer, acid rain is a rain that becomes acidic. What is acidic? Acidic means the one who has pH less than 7. Especially for rain, the pH if it is less than 5.6, then it is called as acid rain. When pollutants like sulfur dioxide and nitrogen oxide, sulfur dioxide means what? SO2. And nitrogen oxide means NOx. NOx means X means any number. It can be 1, then it will become NO, nitrogen monoxide. If it is 2, NO2, nitrogen dioxide. If it is 3, nitrogen trioxide. So generally it is written as NOx. So X is nothing but any number, any integer. So pollutants like sulfur dioxide, nitrogen oxides from industries and vehicles dissolve in it, forming sulfuric acid, nitric acid, and damaging buildings, plants, and aquatic life. So this is the answer. It's very easy. So what is rain actually? We know rain. Whatever water which we can see on the land, stagnant water like lake water, river water, or the water stored on the buckets or anywhere, that all will get evaporate with the help of sunlight. It forms cloud, and those clouds will come back again on the land in the form of water. That is called as rain. But here, what happens? The gases like sulfur dioxide or nitrogen oxide, which are produced in the industries or by the burning of fuel in the vehicles, those all gas is also present into the atmosphere. So when the water is getting evaporated, so when the water stored on the land, when it is getting evaporated and forming water vapors, the gas is present in the atmosphere like SO2, NOx. These all gases will get mixed into these water vapors, and these all together will go up and becomes cloud. So in these all the clouds, these all will be there. So when these clouds comes back on the land in the form of rain, this water and this SO2 gas combines and becomes H2SO4, which is called as sulfuric acid, H2SO3, which is called as sulfurous acid. This NOx, when combines with the water which is coming in the form of rain, it forms HNO3, and which is nothing but nitric acid. So while raining, with rain water, these acids also will get mixed and it comes on the earth, and that is only called as acid rain. And because of mixing this all the acid, the pH of this rainwater will become less than 5.6, and that's why it is called as acid rain. And we know acid is too dangerous. If that acid falls on the building, it damage building, even it damage plants, aquatic life, etc. So that is acid rain. So acid rain means the rain mixed with the acids is called as acid rain. Now the next question, that is B. Which gas is liberated when an acid reacts with a metal carbonate? Very simple. What is metal carbonate? Metal carbonate means metal reacts with carbonate ion like MgCO3. MgCO3 means magnesium carbonate. So CO3 is nothing but a carbonate ion. So whenever any acid combines with the carbonate, see here, acid combines with the carbonate, acid and metal combines to give a salt. Then we will get a water, and we are going to get a gas called carbon dioxide. Remember this. So here if I take acid as HCl, you see what happens? HCl will split to give H plus and Cl minus. Here this is a metal, electropositive metal, which is forming a positive ion Mg plus 2. This plus and this negative combines and becomes what? It will become a salt, which is called as MgCl2 plus. Now this hydrogen combines with some of the oxygen, becomes water, and remaining oxygen will combine with carbon and becomes CO2. So here we are going to get a carbon dioxide gas. So CO2 is released in this reaction. This is the answer. Then question C, write the chemical name and molecular formula of baking soda. What is baking soda? Baking soda chemical name is sodium bicarbonate or sodium hydrogen carbonate. What is hydrogen carbonate? HCO3 minus 1. What is sodium? It is Na plus 1. If I combine these two, plus 1 will get cancelled. What is the formula? We are going to get NaHCO3. So the molecular formula is NaHCO3 and the chemical name is sodium bicarbonate or sodium hydrogen carbonate. This is the answer for question number 23. After this, we are going to move with the next question on the next page. Now question number 24. Draw the diagram of the arrangement of apparatus used to show the action of steam on a metal and label the following part. So here we are going to draw the diagram of action of steam on the metal and we are going to label these two. That is glass wool soaked in water and delivery tube. So this is the diagram from your NCERT book. I hope you know this diagram. It is very easy and very simple diagram. So this question is from chapter metals and non-metal and it is present on the page number 43. So remember the chapter name is metals and non-metals, metals and non-metals, and page number is 43. So if you see this page number, you will get this whole diagram which is very easy. So this diagram has here a Bunsen burner and this is the stand. Here there is a beaker in which there is a test tube which is inverted and inside this test tube there is a water. This is again one more stand. Here there is a horizontally placed test tube and in this test tube if you see one side there is a glass wool which is soaked in water. This glass wool has water in it and this we are going to this portion we are going to keep it on a burner. We are going to heat here. Once we heat, the water from this glass wool gets heated up, it converts into steam and that steam will be passed to this metal sample. So when that steam combines with this metal sample, whatever products are formed, those all the products will pass from this tube and those all the products will goes into this water. So here the gas, that is hydrogen gas which is produced as a product, that hydrogen gas will pass from this delivery tube and enter into this water. Once it enter into the water, because it's a gas, it forms a bubble and those all the bubbles which are filled with the hydrogen gas comes up and the gas will be collected at the top of this test tube. This is the whole diagram. In this diagram, we have to label glass wool and delivery tube. Means we have to label this glass wool and then we have to label this delivery tube. So only two labeling we have to do in this question. But in other questions, they may ask hydrogen gas, they may ask metal sample, or they may ask this water, etc., etc. It is depending on the examiner. So we should practice all the labelings which are there in this diagram. Therefore, I have taken this diagram from the NCERT book, which has all the labelings. So whenever you practice in the house, you practice with all the labeling. But whenever it is asked in the exam, read the question and see what is asked. Here in this question, they have asked only two. So in exam you have to answer only two. No need to answer or no need to write all the labelings. Only for practice purpose, practice all the labelings. So I hope you understood this question number 24. Now we are going to move with the next question. Now the next question is that is section 10. Answer the following question. We have to answer here only one question which carries 4 marks. So this is the last question of this section, that is part B chemistry, question number 25. So we will see the question. A. This question is divided into A, B and C. So first we will see A. How many single bonds and double bonds are there in the molecule C3H7COOH? So we have to count the double bonds and single bonds. So CH3COOH, it is a carboxylic acid. First we will write the molecular formula by splitting the whole compound. So see here how many carbon we have. We have total this C3 and this COOH 1 C, so total 4. So write C, C, C and C with all single bond. Then see the group. Group is our C double bond OOH. It is a carboxylic group. So write down for one carbon C double bond OOH. And remaining all the carbon, write all single bonds and write H, H and H. So total H how many we want? 7. And here if you see these 3 and these 3 6 and this will be 1 7. So this is the molecular formula, structural formula. After writing structural formula, now we can easily count the bonds. There are 3 CC single bonds. 1, 1 and 1. Total how many? 3. There are 3 plus 2 plus 2 is equals to 7 CH single bonds. So 3 plus 2 plus 2. So here how to do these all? So see here 1, 2, 3, 4, 5, 6 and 7. So total 7 CH bonds we have. Total 7. So 3 CC single bond and 7 CH single bonds. Now, the carbon is single bonded to the oxygen of hydroxyl OH. So see here, this carbon is singly bonded with the oxygen of hydroxyl. This is hydroxyl group, OH group. And this oxygen and this carbon is singly bonded. So this we have to remember. There is one OH single bond. So this is also one single bond. So total how many? Total single bonds. 3 CC, 7 CH, 1 CO and 1 OH. So total how many we have? Total we have 12. Once again, if I want to calculate, so see here, I'll write the numbers 1, 2, then 3, 4, 5. Then these are the straight 5 and here also I'll write 6. Now the remaining 7, 8, 9, 10, 11 and 12. So total single bonds are 12. Now what is remaining? Remaining is only a double bond and double bond is only one, which is here. It is only one. So therefore the only double bond is written in the carboxyl functional group, that is C double bond O. So total double bond is 1 and total single bonds are 12. So this is the answer for this A. Remember, whenever such type of question comes, it is very important to remember how to write the molecular formula. Sorry, structural formula. So split all the atoms which are present in this formula which is given and separate all the single and double bonds, and then you can easily count single bond and double bond. Now we are going to move with the next question number B. Write the structural formula of cyclopentane and propanol. Cyclopentane. Cyclo means it has a cycle, means it has a ring. Cyclo. Pent means it has pair. Pent. Pent means 5 carbon. Cyclo means what? Ring. And ane indicates single bond. All are single bond. So I will take 5 carbons. So C, 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 C and C. So these are the 5 carbons and connect these all the 5 carbons with a single bond like this. So see here I have connected and it is a ring. See here it is a closed ring like structure. Now remaining all the valency of this carbon should be balanced by hydrogen. Carbon valency is 4, means carbon can form 4 bonds. Already it has 2 bonds. So another 2 bonds it requires. So I'll write it H. Here I'll write one more H. Same way this carbon require another 2 hydrogens. So I'll write like this. Same way, this carbon requires another 2 bonds, so 2 hydrogen. Here also there are 2 hydrogen and for this carbon also there are 2 hydrogen. And like this we can complete our structure. Combine this and write it. So CH2, then CH2, here also it is CH2, down CH2 and here also it is CH2 and this is called as cyclopentane. Structural formula of cyclopentane. So this is the structure. Now we have to write the structure of propanol. Very, very important. See here, propanol. If you see, prop means 3 carbon, 3 carbon. Ane means single bond. And all means what? It's the alcohol, that is OH group. So start writing the formula. First take 3 carbon. 1, 2 and 3. Single bond, single and single. For any carbon, we have to connect one functional group OH. So I'll write it here. First OH. So OH is done. Now remaining all the valencies of this carbon is satisfied by writing hydrogen. So here see H and H. This carbon has already 2 bonds. I wrote 2 another. This also has 2 bonds. So write another 2H. This also has 1 bond here. It requires another 3 hydrogens. So like this. And in this way, we will complete the structural formula of propanol. If I combine and write, it will be like this. So see here, this if I combine, it will become CH3. So I'll write CH3, single bond, then it is CH2, then it is single bond, CH2, and then the last, that is our functional group OH. And like this, we can complete propanol structure. So this is the answer for question B. Now we are going to move with last. Now the C question is, to see it is very big but it is very simple. Let me read first. Name the substance that do not undergo a chemical change that is used in the reaction of converting a compound containing carbon-carbon double bond into compound containing only single bonds. Write an example for this reaction in the form of an equation. So here we are going to write the reaction of converting carbon-carbon double bond into carbon-carbon single bond. And during this reaction, we are going to use one substance which will help for this reaction. And then we have to write one example. Simple. So see the answer. The substance that does not change chemically but enable the conversion of carbon-carbon double bond to single bond. It is called as catalyst. So catalyst, it is a substance which will increase the rate of the chemical reaction, but itself it will not undergo any change. It will remain as it is, and that substance is called as catalyst. And by using this catalyst, we can convert carbon-carbon double bond into carbon-carbon single bond. And the catalyst used in this reaction is called nickel. That is Ni, finally divided nickel. And this reaction is called as hydrogenation reaction. I will write it here. This reaction is called as what? It is called as hydrogenation because we are going to add hydrogen in this. So you can see here CH2, CH2, add hydrogen and this double bond becomes single and it becomes CH3, CH3. So if I want to explain it in a again simple way, then I can do it like this: CH2 double bond CH2 like this, and then I will add this hydrogen. See what happens? This hydrogen is nothing but what? H and H. This bond breaks, hydrogen separate, hydrogen separate. Even here this bond breaks. Then to balance the valency, this hydrogen combines here and this hydrogen combines here. So see what is the product we are going to get? This newly come hydrogen and these are the old hydrogens. Double bond became single. This is the carbon. These are the old hydrogen and this is the new hydrogen. So it became what? It is nothing but CH3 single bond CH3 and this is the product. What we did here? We added hydrogen and that's why it is called as hydrogenation. But to do this reaction, who is helping? Nickel is helping. But nickel will not take part in the reaction. Therefore, it is called as catalyst. So in this reaction, the reactant is ethene, that is alkene, and one more is hydrogen. And the catalyst is nickel, or we can use platinum, that is Pt, capital P small t, Pt, platinum. And what is the product? Product is here alkane, because double bond became single, so it became alkane, and the name is what? Ethane. Why it is ethane? We have carbon number 1, carbon number 2. So if carbons are 2, then it is called as eth. Because of single bond, it is called as ene, ethane. And in the reactant side, if we see carbon 2, so it was eth, and it was a double bond, so it was E, so it was ethene. So ethene convert into ethane with the help of catalyst called nickel or platinum. So this was the answer for this question C. I hope you understood answer for this question C. Here I have completed part B chemistry for model question paper 2 2025-26, and after this I am going to start with part C, that is biology. I hope you are understanding all the answers of each and every question. If you have any doubts regarding any part A physics, part B chemistry or part C biology, then comment those all the doubts in the videos and try to get it clear all your doubts. So if you like my videos, share my videos with all your friends, and please consider subscribing my channel. If you subscribe my channel, then I will get motivated to prepare such type of more and more videos for you all. Thank you. Thank you so much.